Shortly after its perihelion passage on October 29, 2025, the interstellar object 3I Atlas was imaged by amateur astronomers to have multiple jets coming out of it. The jet structure is best revealed in projected images by applying the Larson-Sekanina rotational gradient filter that removes the circularly symmetric glowing halo around the nucleus of 3I Atlas. Shown in these images, you can see the brightness maps of the projected jet structure within a distance of 25,000 kilometers from 3I Atlas, observed on November 30th, December 4th, 12th, 27th, and January 7th, 14th, 2026 by the Hubble Space Telescope. The image was processed through a gradient filter which removes the circularly symmetric glow around the nucleus. On all these dates, 3I Atlas displayed a rotating system of 3 mini-jets, which are equally separated by an angle of 120 degrees from each other. Applying this gradient filter to 6 images of 3I Atlas, taken by the Hubble Space Telescope on January 14, 2026, revealed a symmetric system of 3 mini-jets out to 25,000 kilometers. The 3 mini-jets are separated by 120 degrees from each other in sky projection and are supplemented by a fourth anti-tail jet extending 10 times farther in the sunward direction. The 3 symmetric jets appear persistently in the filtering of 24 other images taken by the Hubble Space Telescopes on November 30th, December 4th, 12th, 27th, 2025, and January 7th, 14th, 2026. Analysis of these images was presented in a new paper that I co-authored with Tony Scarmato. It demonstrates that the jet structure around 3I Atlas wobbles periodically by plus or minus 20 degrees over a period of 7.1 hours. The wobble is likely the result of rotation, with each jet behaving like a misaligned beam from a rotating lighthouse. The rotation axis is oriented surprisingly close, within 10 to 20 degrees, to the sunward direction. In another paper that I co-authored with Mauro Barbieri, we had shown that on January 22nd, 2026, the observing direction of 3I Atlas from Earth aligned to within 0.69 degrees with the anti-sunward direction. During that rare alignment, the rotating configuration of 3 mini-jets might have traced a circle in the sky. My brilliant colleague, Dr. Frank Lokian, noted the symmetric 120 degrees angular spacing between the 3 mini-jets is astounding. It is hard to imagine such a symmetry in a natural macroscopic object. A key question is, are 3 symmetric mini-jets the minimum viable configuration of propulsion devices to reorient an object in 3-dimensional space? Human-made satellite thrusters usually come in pairs on opposing directions. Could the mini-jet geometric arrangement be an indication of active technology? For orthogonal thruster systems, one would need 6 thrusters, with 2 opposing thrusters along each of the 3 orthogonal spatial directions. If 3I Atlas rotates around its major axis every 7.1 hours or so, then thrusters in the direction of the major axis would not be very useful, and perhaps just 3 plus 1 equals 4 thrusters in the plane orthogonal to the major rotation axis are sufficient for some sort of technical manipulation, like attitude adjustments? Indeed, we observe a system of 3 symmetric mini-jets plus 1 major jet. Additional data might help to address Frank's question. The symmetric jet structure is just one out of 18 anomalies of 3I Atlas. Identifying one of them as a clear technological signature would boost the rank of 3I Atlas high on the Loeb classification scale. Scientific work requires patience, since new knowledge comes one day at a time. Life brings joy when each day teaches us something new. My morning jog at sunrise today was decorated by symmetric, fresh snowflakes. There is nothing more invigorating than the beauty of symmetry in nature, both here on Earth and in the sky.